Alright, hello everybody. Let me first say, welcome to E-Day. We are going to do something that is a little bit of a review. We're going to be talking about special right triangles. And since we did this in geometry, it really is going to be a review day. We're going to do a quick little assessment quiz on Schoology when you're finished. So I'm going to move through this video rather quick, knowing that you can slow it down, go back, you can watch something again if you need reminding. Some of you just need a refresher, and we'll go, oh yeah, that's what we did, and won't need too much reinforcement. Some may need to kind of relearn it, so you can watch this over again. But know, since this is a topic of review, I'm going to move through it pretty quick. So in special right triangles, we hit this right at the second semester of geometry, and I will remind you guys that there are two types of special right triangles. The first one is 30, 60, 90 triangles, like over here on the left, and we have 45, 45, 90 triangles. Now in each one of these little sections, when we talk about 30, 60, 90 first, and then 45, 45, 90, I'm going to remind you guys kind of where they came from. Not that you need to know that. Really what you need to know is how do they work? How, given one side, can you figure out the missing sides? Okay? And again, this is a tool that allows us, given very little information, to find the majority of the remaining information. So, starting talking about 30, 60, 90 triangles. Here is where it came from. If you have an isosceles triangle and we dropped an altitude, it would cut this bottom in half, and then if you did the Pythagorean theorem, we would find, like for the missing side, we would find that we have this relationship. The short leg is 1, the hypotenuse is 2, which is exactly double that, and the relationship from short leg to the long leg is you would multiply by the square root of 3. Here are these things written out in equations. If you were taking notes, which I would encourage you to do, this would be what you would want to write down. Remember, the hypotenuse is 2 times the short leg. So all you're doing is taking the short leg, multiplying it by 2, and that will give you the hypotenuse. Which also means that the short leg is half of the hypotenuse. The long leg is the short leg multiplied by the square root of 3. Which also means that the short leg is the long leg divided by the square root of 3. I hope that is unsettling to you that we have a square root in the denominator. As a reminder, if it does not cancel, you will have to rationalize. So let me take just a second, and I'm going to provide just a couple of examples. You'll have some space to work on the next page. But for right now, just kind of follow along with this. Here we are given this 30-90 triangle, and we don't know what the missing angle is. I hope you remember that these add up to 180, so it is basically implied that this is 60, although not always given. And the key to 30, 60, 90 triangles is always figure out the short leg first, which is the leg that is across from 30. So if we are given that, it makes our life really easy. Let's imagine our short leg here is 3. If we want to find out our hypotenuse, we multiply our short leg times 2. So we simply double it to 6. And if we're going this direction to find our long leg, we take our short leg and we multiply it by root 3, which is often as simply as just adding a root 3 on top of that. Now, we could be given any other variety of things. We could be told that this hypotenuse is 8, in which case we would be dividing by 2 to find that our short leg is 4 and our long leg is 4 root 3. We could be given that our long leg is, bad handwriting, is 5 root 3, in which case we divide by square root of 3 and we get 5, which would make our hypotenuse 10. Again, all we're doing right now is just kind of navigating our way around. Probably the most complicated problems are when we are given something, either a long leg without a square root, for example 12, and we need to figure out what our short leg is. I'll take a little scratch paper over here. We're going to divide by the square root of 3, which means we have to rationalize. Divide by root 3, This is going to give us 12 over 3, which is 4 times the square root of 3. So our short leg is 4 root 3. When we double that, so multiply times 2, be reminded that it is outside times outside and inside times inside, so this gives us 8 root 3. Alright, and finally, we could be given dimensions of a triangle and asked to check, do they follow kind of what we said, what we thought? Well, here this is 8 and this is 4, so that means the hypotenuse is twice one of these legs, and to go from 4 to here, we multiply by the square root of 3, so we indeed have the dimensions, or at least it's following the rules, which would tell us that this is a 30, 60, 90 right triangle. Alright, so here are a few problems that you can work out on your own. This is where I would pause the video and do these. Alright, assuming you have taken the pause that you need and you are coming back to us, I hope you would recognize that x here is going to be equal to 6, which means this is going to be 12. Just an opportunity to check your work. Again, this triangle is rotated a little bit, this second triangle over here. So to go from a short leg of 2 to a, actually I'm going to work in a different color. To go from short leg of 2 to a long leg, we would multiply by root 3, so that would give us 2 root 3. And to go to the hypotenuse, we're simply doubling it. In this case down here, we are given the long leg, which we would need to divide by the square root of 3, which is going to give us 3 root 3, and it's going to give us a hypotenuse of 6 root 3. Finally, checking the dimensions, we would look at this and say, yes, it is a 30, 60, 90 triangle, which means that this x value right here is going to be 30, and our y value is going to be 60. Carrying on to 45, 45, 90 triangles, our other special case. One thing that I want to kind of remind you guys of is if we have base angles that are congruent, it means that it is an isosceles triangle. That will be important because we may be given more limited information in these cases. So if we had a triangle that looked like this with isosceles triangle with sides of x, we could do Pythagorean theorem, and it would tell us that our missing side is x times the square root of 2. So here are our rules kind of written out again, just as a reminder. The hypotenuse is equal to whatever the leg is times the square root of 2, which means that a leg is equal to the hypotenuse divided by the square root of 2. Again, we must rationalize. So here are some examples in this case. Let's see. If we were told that this is we would only have to be told one of these things, but if we were told that this is a 45 triangle, if this side is 3, the hypotenuse is 3 root 2. If the hypotenuse is 7 root 2, then the legs are going to be 7. A little more complicated, or probably about as complicated as it gets. Occasionally, you will see something like this, where the side may have a root in it. So 7 root 2. Our rule doesn't change. The way we go from leg to hypotenuse is we multiply by root 2. So we would have 7 root 2 times root 2, and root 2 times root 2 would give us 2. So this would end up giving us 14. And finally, if you had something like this, a problem of 30, go in the opposite direction. We are dividing by the square root of 2, so 30 divided by the square root of 2 means we have to rationalize, and we end up with 15 root 2 as our legs. And that is going to be true for both of our legs. Occasionally we are given all of the sides and asked to find the angles, and again we would check, is going from the leg to the hypotenuse, are we multiplying by the square root of 2? Yes we are, and we would determine that both of these are 45 and 45 degrees. So it is a 45, 45, 90 triangle. All right, I'm going to try to wrap this up, so take a second and solve these problems for me. All right, I hope that you stopped the video in order to figure these out, but we would recognize that each of these are 45, 45, 90 triangles, so this would just be the other leg, so it would be 3, making this 3 root 2. Here we are dividing by the square root of 2, which means x is going to be 4 and y is going to be 4. Down here in the bottom left, we are dividing by the square root of 20. I'm sorry, we have 20. We are dividing by the square root of 2. So 20 over root 2. We would rationalize root 2 over root 2, and it's going to end up giving us 20 root 2 over 2, which is 10 root 2. In this last problem, again, we're checking to see, is 5 root 2 times root 2, does that give us 10? Indeed it does. So both of these are 45 degrees. Alright, and finally, this video is running a couple minutes longer than I was hoping. I'm going to leave you with the so what. So why this again? And here is the reason why we are reintroducing this to you guys. We're going to show you something very shortly called the unit circle. And anytime you have a circle, there's potential that some things show up. So here we would have, let's say we have this circle, and this is a 30 degrees. Okay. If we were to try to figure out the coordinates of this point right here, we would go to the right a certain amount, and we would go down a certain amount. Okay, so we are looking for an x value and a y value. Let me write that in a better spot, and a y value. And in the unit circle, the radius is always going to be 1. So given this side, or this side of a triangle, naturally our 30, 60, 90 triangle shows up. Okay. Similarly, let's see, we could see, I'm going to cut that, we could see if we had a mark like this, and we wanted to figure out what are the coordinates of that point. Dropping a line straight down would give us 90 degrees. We already said this was 1, and what you'll recognize, if this is 45 degrees, that we end up, the coordinates of, again, this point, end up being the legs of a 45, 45, 90 triangle with a hypotenuse of 1. So the reason why we're going over this, again, is because it's going to show up in our unit circle. Okay. One last final example I will give is our last option. It would look something, would look something like this at 60 degrees, again creating a 30, 60, 90 triangle. Okay, so it is on the way. With that, I'm going to leave you to take your quiz on Schoology.